All right, hello everybody. Let's see, looks like I got sound into OBS. Let me just shuffle the chats around here. Actually see all of these. Happy Friday indeed to Tammy and Liz. We made it out of beta. I call Thursday Beta Friday because it's just like Friday except that it's followed by a weekend. Feature is broken. I like it. Friday the 13th, yes. How's it going, Paul SK? Welcome. Randall over in the YouTube and Beata. Nice, yeah, thank you for the heads up on the audio. Deshipu, how's it going today? All right, so let's do a quick introduction, and then I'll dive in. So hello to everybody. See, I switched the scene. Yeah, we got the scene. Okay, so let's put that back. Hello, everybody. My name is Tim, and I go by Foamy Guy on GitHub and Discord. And this is the deep dive stream, originally started by Scott, the lead developer of the CircuitPython project. But he was away for a little while on parental leave. He did, I think, return back to work this week. He's got a couple of months in, and then he'll be gone again for a little while later, further into the later part of summer, I think it is sometime. So I've been filling in doing the deep dive streams. And then I think, eventually he may be taken back over, but I don't know exactly when that will be, if it's going to be before he leaves again, or maybe not until he gets back after the second time. But I do think we'll maybe have some interesting stuff. We'll try to get together and do a joint one at some point. I think that's in the works, so look forward to that coming up in the next couple of weeks, I would guess. But backing up just a bit, if you are brand new to all of this and you don't know really what we're talking about, on this stream we are going to be working with CircuitPython related things, specifically, developing either like parts of CircuitPython itself or the libraries or examples and other projects that people can use. If you don't know what CircuitPython is, you can head to this webpage to learn more, circuitpython.org. Basically, though, this is a version of Python that runs on these tiny computers called microcontrollers. There's a bunch of them that you can see examples of here on the downloads page. And we're writing Python code that runs on these devices and allows them to interface with other hardware, connected either via the I/O pins, or some of them have hardware connected on board, like the Circuit Playground Express has a bunch of sensors and a speaker and a bunch of RGB NeoPixel LEDs on board. So we're writing Python code that can interact with all of those components that are connected to it. Specifically in this stream, I'll be working with these ones. These are a couple of different sizes of the Adafruit Pi portal. The nice thing about this microcontroller is that it has built-in Wi-Fi in this chip over here, and it also, as you can see on the front there, has a nice big built-in display as well as a touch overlay. So we'll be writing some code that will draw stuff onto the display, and then we can interact with it through the touchscreen there. Adafruit is the company that sponsors CircuitPython, the development. That's the company who's paying the core team that's working on CircuitPython, paying some part-time members of the team, such as myself, to work on CircuitPython, as well as do this stream. So if you do want to support the CircuitPython project, one of the ways you can do that is by purchasing hardware from Adafruit. And this is their website, adafruit.com. They sell all sorts of the microcontrollers. They also sell all the sensors and other components, LEDs, speakers, buzzers, beepers, buttons, anything really that you could imagine that you're able to plug into a microcontroller, they probably sell on Adafruit. So head there. Again, if you want to purchase hardware, then that definitely is helping to support the project, and all of us who do work on the project do appreciate it when you purchase hardware from Adafruit. If you want to get involved in the development, CircuitPython is an open source project, so you don't have to work for Adafruit to get involved. You can actually, if you just go to circuitpython.org, there's a contributing link here. And on this page, there's a list of open pull requests and open issues, and these tend to be the ways that we get folks started in development in CircuitPython. In particular, on the open issues, there is a good first issue filter right here, which has all of the issues that we've identified as being relatively easy or not requiring prior experience necessarily with CircuitPython. So head there again if you want to get involved in the development. And the other thing I would say is if you do want to get involved in the development, I would encourage you to head over to the Adafruit Discord. I think it's still linked down below, right? Yeah, linked down there at the bottom of the screen, adafru.it. All of the folks who do work on the project regularly do hang out in that Discord, and we have discussions and weekly meetings and all kinds of things related to the development. So you can get involved by heading there and joining the discussion. So today, what I'll be working on is kind of continuing on the tab layout adventure that we've been on the last couple of deep dive episodes. At least last week for sure, we did the touch interaction. This week, I'm going to try to put that tab layout to the test and make some more kind of advanced examples that utilize it. So the first example, or I'll say actually the first two examples, because we had a touch one and a simple test one that didn't even use the touch. Those two are very basic. They do kind of the most basic thing. They throw a couple of labels into the layout, and then they just sort of change between the pages, and that's about it, right? They're not really reading data from a sensor or from any other type of component. They're not live updating data on any of the pages. They were just, very, very basic. They were showing how to create the tab layout and show it on the display, and then that was kind of it. They don't really show you how you might use it in a an application that actually is fetching live data from something, be it a sensor or be it the internet or be it whatever, and actually updating the display with that information that you're fetching. So that's what we're going to work on today. Starting out with, I'll actually show one of the examples that a community member has made, Paul, over in the Discord chat. So hug reports again for Paul. Paul created this example which we will look at first, and then I'll kind of tweak and tinker to fit the hardware that I have here. And then depending on how much time that is taken, then we may also work on some other examples I have in mind for the tab layout. Ultimately, the goal is kind of to try to recreate this interface, which is in this PyPortal user interface Learn Guide. This one is relatively old. I think this was created back around the same time that DisplayIO was introduced. So it does work, but there's lots of stuff that has been made easier since the time that this was written. So I'm trying to create kind of a modern version of this thing that shows like a relatively advanced interface like this. Multiple tabs, different controls on each tab, different live pieces of information coming from sensors and things on the different tabs. So this is kind of our end goal, and today will be kind of one of the other stepping stones on the pathway towards that end goal. If you are interested in the tab layout or any of the other development that I've done that has made some of this stuff easier, you can check out the prior streams. I've done a lot of work on both the deep dive streams, which are Friday afternoons right now, but also I stream on Saturday mornings on my own account on Twitch and YouTube. And I do hang out in the same Discord chat room when I do that, so you can head there to interact when I am streaming on my own channel as well, same way. And you can see like all the development kind of that has gone into these different widgets and things to make this stuff easier. So if you're interested in the history, you can check that stuff out. To start with, what I'm going to do is I think pull up, so first of all, we can plug in a device, and then I think I'll start with this example which Paul shared, and we're going to be making a PR with this, I think, to get it included in the DisplayIO layout library. Right now, it's not. It is pushed into GitHub, but it's not in that main Adafruit repository yet. So we have just a little bit of work, I think, that I want to try to do on the Pylint side of things before we do make that PR, but then once that's in, we will make a PR, and this example will get added kind of to the the official repository, and folks will be able to find it there and in the documentation. So I'll plug this in. Here's an example of the layout. I think, does this one have touch? Yeah, this one does have touch, and one thing that's weird about this one is I have this pink block on it. I'll go and take that off. Basically, last night I was doing some testing on this, and I drew this block to try to get a measurement, essentially. I drew this block a certain number of pixels tall, and I was comparing it to the tabs to try to verify what size the tabs actually were getting shown on the screen. So that's what that's about, but it is kind of just covering up that first tab there. It was kind of like just a quick and dirty way to measure something. I kind of do that a fair amount when I'm working on widgets. If I want to measure how many pixels something is, then I'll just draw a shape with a known amount of pixels and then put it next to it, and then of course I can just look and compare. See Grover here? Not yet. Okay. Well, I guess I shouldn't say not yet. I don't know if C. Grover will join us. If C. Grover does join us, I have an idea that they may be interested in, hopefully. Because the other thing I did last night was actually calibrate the touchscreen on my PyPortal Titano, and I used a script that C. Grover created for that. So first, let's just get rid of the pink box here. We don't really need that anymore. And this is actually, let's see, this is actually not Paul's example. This is the touch example, the base one that got put into the repository before. So actually, we can just leave that. We don't even need to remove the pink box, because what I'll do is I'll just copy this code over. I already have another copy of this anyway, and it's in the repo, so I can just remove that, paste this one in, and now our pink box will be gone. Oh, wow. Got the buzzers. Hopefully that wasn't too loud. The phone just buzzed on the desk here. Okay, so right now this one does have Pylint disable all, and so that's what I'm going to try to do, is actually undo this disable all and then go through and work through the remaining Pylint complaints, basically. Instead of doing that directly right on the device, I think what I'll do actually is go ahead and open up the repo, DisplayIO layout, which is, well, that's one of them, but not really the one we want. Do I not have another one? It must be in that list. I just missed it somewhere. Okay, hold on. Let's go open recent and just do one of these. New window. Now we can go open. We're actually in the right folder. Yeah, there it is. DisplayIO layout. It's TabLayout example. So I think we don't need the changes I have here. Let me double check what I have. Yeah, we definitely don't want that. Last night, along with doing some measurements, I was chasing what I thought at the time was a bug, but it turned out to just be calibration on the touchscreen needed to be done. And as part of trying to fix what I thought was a bug, I ended up changing the tab layout, because I thought it was going to need a change to work as intended, but turned out actually not. I don't think to need that. I mean, it may still need something, but the specific thing I had in mind was not the case last night. So let's go here. I think doesn't have anything else to commit, right? Okay, so we should be able to change branches. Adafruit main to start with, and yeah, I'll check out main. Let me check out main, but then what we'll do is we'll actually make another new branch, Adafruit main. Here we go. And I'll pull, or fetch maybe. Is it gonna update for me here? Because it, I think, has been updated since I used it last. Maybe not though. Looks like we got the latest. Okay. So I think to see all of our Pylint errors, what I'll do is make a new branch. Git checkout -b. New branch name, I'll say Paul Advanced Tab Layout, Tab Layout Pylint. I don't know, I like using pretty specific names even though they're kind of wordy. The branch we want to go from, Adafruit main, and then we can do no track. This way our remote will not be set to Adafruit main. When we go to push, we'll be able to specify a different remote and a different branch. Speaking of remotes, what do we actually have for remotes? Okay, Foamy Guy and Adafruit, that should be fine. And then actually, I guess one thing is I do need to check, is this the touch one or is this not the touch one? Because there actually are a couple of different ones of these, right, I think. So, well, first of all, we don't have it open yet. So over here we do, though. This one is the touch one. Let me actually grab the non-touch one, because I think that was the one that is pushed into GitHub already. Let's see here. This one is the one we want. And one of the really cool things about this example is it has a bunch of error handling and like reconnection logic for the sensors. It's set up for 2 sensors, or I say sensors more generically, like just a component that's connected. It's actually one RTC, real-time clock module, and then one temperature sensor, which is actually a more like a real sensor. But it's cool in that it watches for those things to get connected and get disconnected, and it handles it gracefully. So you can actually just run the program and then connect them up afterwards, or disconnect them and reconnect them, and the program will notice that they got either plugged in or unplugged, and then start grabbing data from them. This is in hot plug sensor examples here. And we'll go back and play with the touch one as well a little while later, I think. But this one is specifically more like the simple test. It uses the doesn't use the touchscreen, but instead uses the just cycling through the pages using the function, like test page layout, next page right here. Time sensor, it senses the flow of time. That's true. That's definitely true. And I also don't know, I do know my RTC is different than the one that's in use, so I'll eventually hook up my own hardware to this stuff, but we will have to change a little bit of it. I have a different RTC, I have a different temperature sensor, so we'll have to tweak some things. The good news is that most of the Adafruit drivers are actually pretty well built around the same APIs. There's like a style guideline where the drivers are built using these same sort of styles. Each time a different type of driver is written for, or not a different type of driver, but a driver for a different device. Like all the temperature sensors have a very, very similar API. All of the RTCs probably have a very, very similar API. This way we can kind of like swap the initializer function, and hopefully we won't have to change too much else of the code in order to actually have it start working with the new sensor. So what I will do is, I think we could just create the same folder in my local one here. Hot plug sensor examples, I'll just make it like this. Examples. Hot plug sensor examples. And then we'll do this file name. Python file. Oh, name of it, yep. Yep. I hope this does not have a space at the end of its name. No, okay, it doesn't. Thought for a second the way I copied it from the web there might make it do that. Whoop, need caps lock, let's put that. Quartz crystal is how it does the sensing. Interesting, yeah, some kind of fancy crystal that pulsates when you give it electricity for some reason, or pulsate's probably not the right word, but changes its electric conditions, basically. So to start with, we can take that off, and then let's just run pre-commit and see where we're at. Oh, you want to run it though, run A. Okay, so we got a little bit of reformat from black, and then we got these ones, which are, there's not too many. So Paul actually did a really good job knocking out this list. There was a much longer list, and most of them are actually handled. You can see we're at 9.84, so we're pretty darn close to the perfect 10 there. What is this? Line too long. That one's fairly easy. We're not too... we're long by like a character probably. But what we can do is just find a good place to break this to the next line. Function sets page 4 label to default text and makes empty label 2. So let's just say maybe makes empty and then put those on the next line. Save that. And that should fix the line too long, I think. Global ones we'll have to figure out here. Duplicate key in 3 dictionaries. Oh, yep, we have 3. Yeah, 3 and 3. One of these should be 4, I think. Small typo there, probably. Okay, what is this one? Global. Okay, so it doesn't want us to use global. So let's take a look at how the code works a little bit. I think the reason why it's trying to use global is because it's ultimately trying to put the sensor into this variable, which belongs to kind of the outer scope. Like this variable first gets created right here, and we want to be able to update it inside the function, like update it from inside the function. In order for that to actually work, we need to access the global variable. A couple of these as well. What are these ones? Are these labels or strings? Okay. So one thing we could do is we could put this stuff on an object, I think, and then it wouldn't need to be global anymore. Another thing we could do is like refactor this function to return the things that it needs. And then set them like outside of the function. When you call it, you get the return, and then you set it into the variables. That's another possible way to do it. Might you use the TabLayout example to show off? Yeah, that's definitely the plan, DFG, over in the YouTube chat. The longer term goal of creating the new version of this one. When we first do it, it will not be async IO, but that is the ultimate plan, is to actually make this project also utilize the newer async IO library and functionality from core CircuitPython. So what we'll do is we'll build it synchronously first, and then work on refactoring it and adapting it to actually use asynchronous code. Ultimately, so that will be the goal. I have no idea, truthfully, if it does work with async IO today. There might be changes that need to be made in the tab layout, and we'll definitely cross that bridge when we get to it. But that is the goal: is to ultimately show this relatively complex interface and show it using the async IO APIs. So I'm sure there are other ways probably to solve this as well, and I'm thinking that I think I want to go with basically like a context object, where I'm pretty sure if these things are part of another object, if they're an attribute on another object, then I think we can set them from in here even though the thing is not global. Which is a little weird, but I think that it does work that way. I think what I'll do is try that first. So basically every one of these variables that has a global, there are basically 4 of them here, 5 of them. The sensor, the Boolean that represents whether it's currently connected or not, and then the 3 strings here. And then on the clock, it's again a Boolean that tells you whether it's connected or not, the actual driver object itself, and then else start, that one I don't know. Is that maybe the time? Nope, this one is a Boolean. If else start, then set it to false. RTC connected. I'm not sure what that one represents all the way just yet. Get temp. So in this one, we can we could pass in the objects we need. Because this one I assume is not actually setting any of the variables, probably. This one would be accessing the temperature from the sensor, formatting it into the string, and then showing it onto the label. So it has return value, but that's a local variable. That one's not global. And okay, it is setting a few of them here, actually. So it is setting the Boolean. It is setting the object. These ones are all the label attributes. Handle date time. So this one's probably going to be similar. Mostly this one's going to be getting the data from the RTC. Well, no, I guess it's going to get passed in. We're going to have the date passed in here, it looks like. Similar thing here. Yeah. So I will say one thing is, I think, are we down to just one kind? It's a flag to indicate the boot time situation. I gotcha. Okay. I think, well, using global. Well, okay, a bunch of these are using global but no assignment, which actually means, I believe this means that they don't need to be global. So for instance, it's telling us on which ones. It's telling us on all the labels, it looks like. In fact, in all of these cases, they're all the labels. I bet you then that we actually probably don't need global on any of these. Global's a weird thing. Like it feels like you would need it to access the variable, but you actually really only need it if you want to set a new thing back into that variable. And even then, I think you only need it if you want to set like the entire variable itself. If you have just a single attribute like this one here, page4label.text equals a new thing, we are putting a new thing into a variable, but because that variable is actually an attribute on this object, it doesn't require it to be global. I'm pretty sure, and we're going to try it here in a minute, so we don't have to take my word for it. That's my understanding as of right now, though. Yeah. So I guess let's just start with those ones, because those should actually be pretty easy. And then, realistically, if we needed to, we could pilot ignore the remaining ones. It would be best to get those solved as well. But if we are down to a single type, then we might be able to get away with just disabling that one type of error, I mean single type. So let's start by trying this. Basically, we just don't need, because none of these get set. Again, that's the attribute getting set. Yeah, so I think we could go none of these ones. And these ones. Oops, too much on that. There we go. Okay. Let me see. I think that gets rid of probably most of them, except for like the first two, maybe. Not quite. We got a couple more than two. Not by much, though. And it does get us down to only these ones, which are just generally flagging on the fact that we have used the global statement, which is not considered best practice necessarily. According to Pylint, this is. And so I think in all the remaining cases, though, we are actually trying to set the variable. Like here, we're setting it, so that one either needs to be global or we will need to refactor it to work differently. 0 seconds, yep, this one's definitely setting it. C seconds, that one is as well. Refresh, yep, that one is being set also, and this one, yep, also is getting set. So all of those either have to be global or we have to refactor it. That one is being set. Hold temp. Yep, being set there. This one, only in the exception does it get set, but it is still inside the function, so it does fall into the same category, and this one as well. And this one too, yep, RTC probably in the exception, or... this one oh, nope, does get set right there. Missed it right at the beginning there. And this one as well. And that one... TMP, yep. Strings, I think, are right. Yeah, they're all set to none here, and string values here. Okay, so that is all of the remaining ones are just those globals. What I will do first is let's grab what we have so far, put it back on the device, and make sure that I haven't broken anything yet. Okay, so far so good. We'll connect to REPL also. That's actually pretty good. We could do that. So we do get no RTC found. Maybe we did break something because there were other labels. Let's say this. Let me try running the original one more time. Actually, not one more time. I never did run it this time around. I ran this one last night, but not during the stream here. See if I did break them. Maybe I'm wrong about those labels. I was thinking we could get away with no globals on those ones, but let's see. No, okay. Yeah, it looks the same so far. So I think it's probably because we don't actually have the sensors connected, then we're not seeing anything in the other labels. Especially because, like, in the else here, it sets them to blank. And here as well in the exception. This one maybe it's like the old value. So if it was blank before, it will end up blank again still, it looks like. Okay. Okay, so let's try to connect some of our own devices. So I don't have TMP 111. What I do have here though is AHT20. Actually, I have a couple. It's a TMP 111. That's a temperature sensor, and I actually have these two here. AHT20 and a SI 7021. Those are both temperature sensors as well. Let me connect up one of those, and we may end up having to switch to the PyPortal standard instead of the PyPortal Titano, because I have not soldered the little jumper thing on the back of the Titano yet, and I think some stemma things don't like the default, I don't know what it is, I guess logic level voltage or something. There's a little jumper on the back of the PyPortals that you solder to change something between 5 volts and 3 volts, and some stuff needs it to be one, and some stuff needs it to be the other, and I find more things that need it the opposite way from what it comes stock. So I find I generally do end up having to solder that thing, but we'll try it out here. AHT20. To start with, let me actually grab, well, actually, let's just connect our, let's take a step back from the tab layout stuff and just get this connected and make sure everything is working fine with that, so that we don't start questioning like whether or not we actually have that part set up correctly. I'll go GitHub. Oops. Oh, that got us there anyway. Let's see, we could replace RTC present. Yeah, I was thinking that as well, RTC present. Instead of the separate Boolean, it could also just be checking the driver object if it's none or not, because it looks like it always gets set to none anytime it notices that it's not connected. So therefore, it could theoretically just check if that thing is none or not, I think. So that would get us away from one of those, well, a couple of them, I guess, actually two of them, of those global variables. They both serve the same purpose, just one for the temperature sensor and one for the RTC. So let's take a look here. Did we get some temperatures? Okay, no module. That makes sense. We didn't install it. You know what I kind of want to do one of these days? It's not really a practical project, but I think it would be fun, is to set the storage to writable, for one thing, because you would have to do that. But then make like a true hot plug I2C like program that it will constantly scan the bus, and then when a new thing connects, it will get its address, and then it will have a map of all the addresses to all the drivers, and then it will automatically download the driver for the device that got plugged in, and then automatically connect it and start reading the data. That's a lot of like dynamic stuff. It would be kind of hard to make that. But I think that would be kind of a cool, just like example of showing a CircuitPython program that actually kind of like is very dynamic. It does stuff based on what's plugged in, and it grabs the right driver for you, because all the drivers are out on GitHub. It could download it with Adafruit requests or something like that, I think. All right, so we are getting temperatures here. We're good to go there. And so our initialization is pretty similar. What I'll do, I think, is copy this to AHT20 simple test. We'll go back to the one we started, editing here. It works in main if I replaced RTC present by if RTC is not none. Nice. Nice. So I'll make that change as well. Basically, this one is, instead of using the present, let's see, so main is down here a bit. Instead of using the present, these can be if RTC is not none. And the else is there as well. And then this one would be if, is this one temp or, let's see, this one is TMP? Yeah, that's is not none. And then we're going to end up changing TMP as well. But maybe what we do is go back here. And then for my version, what I'll do is refactor rename. And then I'm going to rename this variable to temp sensor. Yeah, temp sensor. Since ours is going to be a different one now. Excuse me, and then PyCharm will rename that everywhere that it gets used. And so then what we'll do is we'll take this out. I'll leave this clock one for now, but we'll end up switching that as well. Okay, and then initialize it. Well, we already have another name for it, though. Oh, right, temp sensor equals. And so we want to find the places where it's getting set to things other than none, which here is one of them. Oops, I already have an equals. And that one is none. We got our one spot here inside connect temp sensor, which makes perfect sense where that would be creating this. Yeah. And then I think we're probably always doing the, ooh, okay. Just took an extra second to save there. Temp sensor dot temperature, which we should still have. Yep. And yeah, that's the only thing that's accessing something from temp sensor. So just like I was talking about before, because all the temperature sensor drivers use this temperature property to expose their data, this means like we didn't really have to change very much. The initializer, the import, that's pretty much it. I chose to change the variable name, but of course you could name your variables whatever you want. So that would have worked even with the old name. Oops, let's go here and see what we have. Oh, nice, there we go. Our temperature, it was on page 4. We'll let it cycle back through. There it is, 23.05. I could possibly influence it. It's a little warm in my house today. 2410 right there, updated the data live. So we got one, and it looks like that's connecting. What does it do? Does it change? So let's unplug it here. Unplug, and then let's see what it says this time back around. I think, does it change the, okay, just goes back to empty. But then we could always just plug it right back in. There. And it may take it one extra cycle to catch up, because I did it like right before it was about to turn, I'm guessing. Let's see what we get here. Yep, temperature's right back. So look at that. That's amazing that we can kind of just like put the circuit together as the program is running, and the program, like, it never freaks out. It has error handling in all the right spots. It has reconnection logic in all the right spots, so we can just plug and unplug this thing, and we continue to get live data when it's plugged in, and the program doesn't crash or do anything bad when it's unplugged. So again, this is awesome. Thank you to Paul, who created this, this hot plug example based off the TabLayout example. I think that this concept of all this error checking and this live like reconnecting logic, I think lots of people will probably find this pretty helpful in different projects. So I'm pretty excited to get this example out there and shared. And we do, it seems that we didn't really break anything, right, with those labels that we removed. So we can, I think, go back and, well, actually, let's try to connect the RTC. Now the RTC I have is different. And I'm not sure it's gonna work. Don't know for sure that I've ever used it. Oh, you know what? I do not know which colors are which. Is blue SDA or SCL? So mine is a DS1307. This one, I believe. This is actually an older package. It doesn't have any of the newer style yellow, green, yellow, blue, red, black stemma cable looking. These are different guides. This one actually goes to the breakout. Well, we may just try it out. Or you know what we could do is look at a different thing. Maybe let's look at Olaf from Colorado. I never remember the colors and guess. Yeah, we might. I might just guess. Let's try one other thing. I'm gonna search AHT20. This is the one we already have plugged in, and this will probably have Viata, yeah, I have trouble remembering the colors as well. So I will say, yeah, Adafruit's pretty standard, I think, as far as the yellow and blue go, because a lot of what I use these days are the stemma cables, which is what I have here is one of the, it's stemma on one end, and then it's broken out on the other end. I also have this one here, which is like big stemma on one end, and then small stemma on the other end. I don't know if big stemma is the right term. I'm probably butchering that. I'm sure there's an actual specification for it. But even though I typically use those a lot, I don't quite have it memorized. But I do know that these pages, some of these pages, like this one here, this will show us. I believe they do these the same color. So SCL, it has as yellow here. So I believe SCL then is yellow in the stebas as well. It's an older code, but it checks out. We're gonna go, and one of the cool, oops, let me switch to the camera. One of the cool things about all these little stemma breakouts is these are chainable, right? This has one plug on one side, another plug on the other side. So we can now plug this one here and then wire up these things. So I'll go ground. Ground right there. 5 volts is next to that. I'm going to do 5 volts last. Yellow. Actually, I don't know if we're going to get 5 volts or 3 volts. I guess we're going to see. Yellow was SCL, we said. Right here. It was a little tough to push in. SDA is right next to that, so that's going to be blue. And then 5 volts is the last one, which will be red. Offset that one by 1 row here to make it a little easier. Okay. And doesn't look like there is any sort of power indicator LED on this thing, so we don't necessarily know if it woke up, but what we'll do is start trying some code on it. Which actually, I think this didn't say CircuitPython, did it? We need to... It's maybe time to re-up this guide. Yeah, because this one doesn't have CircuitPython, but I do think there is CircuitPython, GitHub. Was it DS 1307? Is that right? 1307? Yeah. And examples here. Simple test. Nice and easy. So actually, let's go back to here. I'll take my updated code here and put it in my edited file like this. Save that. And then I'll put the RTC simple test here. I like, whenever I'm like connecting a new thing to a more complex program or a complex circuit, I always like to take the simple test of each thing and like make sure that it actually is connected and is working how it's intended, and then kind of like intermix it in with the larger, more complex thing. This way, if there is a problem with my wiring or with the driver or with anything related to this sensor, we'll know about it before we have a bunch of our code intermixed with that larger, more complex program. Forced moon. Okay, so let's see. We'll probably get a failure for not having the driver. Makes sense. We can install that, no problem. Circup to the rescue right there. Okay. And there we go. We got time. It's not the real time, but it is time. And the reason it's not the real time is just because it's... Actually, to be honest with you, it might be pretty darn close to the real time. Maybe this is like, I'm going to say European, but really what I mean is just months before... I mean days before months. Is that right? No. Yes. Well, is this what's actually printing? Yeah. Yeah, day, month, year. Which feels backwards to me, but this is how a lot of people write it, is day first, and then month, and then year. And so this is actually saying the 12th of May, 2022, and then the time it has is 1635, which was yesterday. 1635 is off by a bit. I'm surprised it knows. Truthfully, though, why does it know? I mean, did we just get lucky? Because my thought was it doesn't... The RTC by itself keeps time, but the RTC by itself doesn't know the time. You have to set the time to it, and then it can keep counting from there. So from that point on, it knows the time. But before you set it, it shouldn't know the time, I thought. So I'm actually fairly confused and kind of impressed that it's anywhere near as close as it is. How's it going? Let's see. Hari Suresh? Hopefully I didn't mess up your name too much. If so, I apologize. I have no idea what you're doing, but that's cool. Yeah, if you would like a quick high-level intro, I can... There's one back at the beginning of the video if you want to catch it, but also I can... I'm happy to give you the sort of 50,000-foot view, again, real quick here if you want. Is set in line. T. So here... Well, okay, so what's false, though? Oh, I see. Okay, so this is basically just like a Boolean you can switch. So it's not going to go here. Instead, it's going to go here. It's going to get T from the RTC. Format it. Sleep for a second. I don't know. Maybe as part of the initializer in here, does it... Of course, we can't look in that code. I mean, we can, but not in our editor right there. It's MPY files on the device, but... When you initialize this, does it like... No, it doesn't really do any like NTP or anything like that. Huh, maybe we just got lucky. Can you tell me how this works? Well, I can't tell you how this little thing knows the time. That part I'm perplexed by. But I can tell you, like, if you mean higher level, like I was mentioning a minute ago, just like generally what we're doing and how it works, we are writing CircuitPython code. So this is the CircuitPython project, circuitpython.org. You can head there to learn more. Basically, how this works is these microcontrollers, like this device right here, is a CircuitPython device. And when I plug it into my computer, it shows up as a thumb drive. This is how thumb drives show up when I plug them into my computer. They come to this, file manager thing here, and they would just show up as a new drive, a new line here. So there's a thumb drive, an external storage connected that's called CircuitPy. On that device, there's a Python code file called CodePy. That's the file that we are editing inside of PyCharm right here. And as soon as we edit that file and save it, it will actually go ahead and run the latest version. So if I did something like print... hello, Hari. Welcome to Deep Dive. And if I'll open the terminal so we can actually see it when it prints. Leave that open, and all I have to do is save the file. I'm just going to press Control-S to save this file. It's going to automatically notice that it changed, and it's going to rerun. And then right there is our new code. Hello, Hari, and welcome to Deep Dive. So this is how we are editing the code on the device. It's nice and easy compared to lots of microcontrollers. Like a Pico, if you mean Raspberry Pi Pico, it is similar to that. The Raspberry Pi Pico is one of the microcontrollers that CircuitPython supports. In fact, at this time, it is the one with the most downloads recently of CircuitPython. So there's definitely lots of Raspberry Pi Picos out there. Ours, this one here is a PyPortal Titano, so it is a different device. It's a SAMD51 is the main microcontroller, and then there's a ESP32 over here that it kind of talks back and forth over the SPI bus. Set at the factory. But it hasn't had a battery in it until today. That's the weird part, is I've had this for probably at least a year, and I just put a battery in it today. So it shouldn't have been able to keep it, I don't think. But it also doesn't matter too much why it knows. We can just say that's cool and be happy about it and move on. It is is very interesting to me that it managed to know. Yeah, because I just put the battery in probably like an hour before I started streaming. Default. But this one, Paul, that's in your script, is it, I think, though, right? This one is just the simple test for this thing, is that right? Or is that... Because this script here is yours, line 23. Yeah, this one here. Maybe did this get set? I bet you, yeah, okay. Yeah. This probably got set into the device time. Because the main chip also keeps track of time. So when we ran this ended up updating the time of our device so that it could actually know the real time. Is that right? I don't see where it would have happened, but I'm thinking that must be what actually happened. Maybe even when you call, what is this constructor up here? Maybe even when you call this, does it set it into the system? Yeah, I think you're probably right, actually, because that is the 12th. And 1834 would have been, that was pretty much the earliest one it had. It's been running for about 8 minutes now, so we're up to, 1842. But yeah, this must be where it came from, actually, yeah. So it is, somehow when I ran yours, it saved it in there. And so now this one has it. So that does make sense. So how are we, so here we're accessing it with t equals rtc.datetime. Is that the same thing that happens in here? Well, and also let's go ahead and take this out for now and swap it for this one. Once you ran it, it sets the time. Yeah, I think so. Okay, I get it now. Nice. And you got this from Adafruit? I did, yeah. So the Pi portal here, this is an Adafruit device. This one actually happens to be also an Adafruit device. So is the one that's connected here. The Raspberry Pi Pico, of course, is not an Adafruit device, although they do resell them. So I think you can buy a Pico on the website, adafruit.com generally, but it's obviously was, produced by the Raspberry Pi company, or I don't know what their official designation is, but so now we can find where the old one of these was set up, and instead of this, we can just swap in this one. I'll undo the comment as well, because the I'm guessing probably the I2C address is different. I don't actually know. We'd have to go look in the code for this one. But my guess is that it is different. This does call RTC datetime equals, and then that datetime equals something else. So we set things into datetime, and then I think also later we will read stuff out of datetime. Yep, right. Nope. That's setting into it. This one here is reading out of it and putting into there. And datetime, it looks like, is the same API here. So same thing I was talking about earlier, where the different drivers use the same API. Therefore, like, it's very, very easy for us to switch between them. That's why I introduced the iStart flag. I gotcha, to only set RTC once. I just wanted to say this RTC discussion is really helpful for the project I'm working on. Great stuff. That's awesome. Yeah, thanks for watching along, and thank you for mentioning that, Struds. I appreciate that. Always nice to, like, hear folks that are interested in what we're working on, what we're talking about, all that sort of stuff. So thank you not only for watching along, but for mentioning that. So we'll erase this for now. Let's go back to here, put this one in code. And I think it's probably just ready to run, right? I don't think I changed anything else that needs too much action. So we got our bus numbers there, creating tab. Now, one thing is I don't know exactly which page the RTC does get shown on, so we'll wait and watch this cycle through a couple of times. We did get found and connected there, so we should be good to go. So page 4 has our temperature. Looks like page 3 is going to have our time. Yep, right there, date time. And again, it did end up resetting it back to that 1834, which was the time it started. And you can have it fetch the time from the internet. It's not doing that right now. But it does. This is one of the cool things about the Pi portals is it does have that ESP32, which is actually going to allow it to fetch stuff from the internet, including like time from an NTP server, and then it could set itself based off of that. But it is continuing to tick. That one was on 48 seconds, I think. Let's let it cycle through again and make sure it's on something more than 48. 34:47. 34:56. Maybe it was 38 the previous time. 34:56. So now we'll be on 35 something. 35:04. Yeah, definitely still counting. So now our temperature and our time is live updating on the different pages as we cycle through them. Let's see here. The need for setting external RTC was I was talking about yesterday. The idea I came up with was initialize the external RTC from an external file. Gotcha. Number 4, NR3. You have network, you can just hit your router and set the time. Oh, okay. It doesn't need to go to the internet necessarily. It could ask the router for the time. That's a good point. Yeah. Okay. So we got this functional. We have not broken it by updating, the 2 drivers or by removing those global variables that we did take out before. So everything does still work. I assume it will still work with the original sensors as well. Of course, I don't actually have them, so I can't test it. So maybe once we get done with this, we'll send it back over to Paul, and he can check it on the original hardware with the circuit that he built that has these devices. I will see what we can do to knock out the last of these. So we're down to just only having the global statement is our only pilot failures right now. And we have 5 of them because there's 5 of these functions. Well, so RTC present, actually, we do know this one. We figured out that we can do if RTC is not none. Do I want to change this here? Yeah, I think so. So we did figure out this one, but and this does, let's see here. So if it's not none, it tries to set it, but then if we got the exception, it does end up setting it to none, which we would ultimately need to set the RTC to none, which we would actually need the global for. Okay. There's the error. And we could actually hot plug that RTC as well, actually. So if we go back to our terminal here, in the camera, I could unplug the RTC as well from this side. And then it notices it right there, probably disconnected. So then it will just be blank on page 3. Or the default third page is fun. And we can just live plug it right back in as well. There. And then it will notice it, I think, within the first or second cycle back through here. Let's put that back too. Actually, maybe I didn't. Or does it only do, maybe it only does hot plug on the temp sensor. Or did I jostle something loose here too? No. Maybe it only does hot plug on the temp sensor. Let's take a look. This is a part of the beauty is actually it should be pretty straightforward to find, right? So we do have a connect temp sensor. We have a connect RTC. Where does this get called? Okay, this is inside main, right before loop number. Maybe RTC is not none. I'm gonna try that. Also the RTC. Okay. Maybe the way we changed the Boolean. Yeah. I think maybe the way that we changed it to use, like where we changed this one to be is not none instead of the Boolean changes the logic just a little bit because, so if it's not none, it goes to here. But I'm thinking maybe that it is not none, but it's also not the driver anymore. Or if it is the driver, it can't access the data. Have it print this also. I see, change it up in here as well. Okay, so we got our first one. Unplug this, try to at least. There we go. Okay, noticed it there. And then I think the next time through it will blank back out the 3 or go back to the default. Well, not quite actually, it does keep this. Then will it show it here? There it is. Ah. Yeah, 3447. $34.55. Yeah, okay. So we just, yeah, we needed to just change it here as well, and then it's back to being hot pluggable. In which case, actually, we can just take this one out altogether. And this one as well, I think. It will blank the labels. So we are connected now. Let me go back to this one, or let me go back to this one as well. Okay, I did make that change here. That gets one of our globals taken care of. Down to 4 now. So I think we can get by without this one anymore, because instead we're going to do that TMP 117 is not none. So we'll still need to refactor those ones. Or ignore. Using a pilot ignore on a single thing, like the global statements is the only thing we need to ignore, that I think is a little bit more okay than the wholesale disable for the whole file of every single check. So even if we did do an ignore on the one global, I think that that is probably okay. There have been projects where I've done that as well. RTC present. Okay. Okay. So I think that we could still refactor this to not use globals at all. I think what I want to do, though, for now, is actually just pilot ignore the global statement check specifically. And again, doing that on one check I think is better than the disable all. And the reason why is because I don't actually know, quote unquote, the best way to refactor it. What I want to do, I think, is put this back in. Whoops. Put this back in to make pilot happy for now. And then what I'm going to do is actually just start experimenting on kind of building a different one of these examples. And in that one, I'll play with a couple of different ideas for how to store data in such a way that different parts of the program can access it. And then once I kind of get my head wrapped around which ones lead to good code and which ones don't, then I'll maybe come back and I could suggest changes to make here. To update this one to work that way. I can never remember the exact right syntax for this. Oh, I found a lot of disables. Colon pilot colon disable equals. So it's statement, statements. Oops. Statement, but I haven't saved it yet. Ah. Yeah, the class. The class is one of the ways I was thinking of doing it. Either create a class that holds those values for you, kind of like how it does in the async.io guide. Speaking of async.io from earlier. This guide here, it creates a... I don't remember what it calls it. Creates like a data... this thing. Creates a class that holds a data value for you. And then it's able to access the attributes of that class from multiple places without using the global keyword. So that's one way to refactor it. I think you could use a dictionary as well if you didn't want to have a class with like specific attributes. There's possibly other ways to do it as well. That's kind of why I want to play with a couple of different ways, see which one I start liking the best. And I'd rather not, like, I could give you my my first guess, and it sounds like actually you maybe have done my first guess as well, but I don't want to I don't want to send you down the road, a road, and then later on be like, oh, actually I tried some more and I decided that this other way I think is better. Head back here, and we did get a clean pilot run this time around, I think, right? Yeah. Okay. save that. What I'll do is push this for now. Homie guy. Okay. So here is the updated version of this with the changes I made. If you have a chance, Paul, try running this on your device with your sensors and everything. Just let me know if I broke anything. It's possible maybe I didn't update some part of it that needed, or I did update some part that didn't need it. Because this one I was editing this in the repo rather than on the device, so I have not actually run this one. But if it doesn't run for you, let me know, and I can work through and fix anything if I did break it. Inside the class, I use dictionary. I have to search for the files. Okay. So that one's there. So now I think I want to start another new tab layout example that will start looking more like this one. So we're going to go portrait for one thing, and we're going to have different stuff inside of these. And we're also going to have some buttons inside some of them. Picture in picture. Yikes. So I don't remember what all the buttons do. We could run this project. Okay, and I think you folks can't hear this, so sorry, you're watching me stare at the screen and listen to this person talk, but running flawlessly, awesome. Okay. So let's start with this. Let's make a portrait one, let's make 3 tabs, let's just start adding the stuff to kind of make it similar to this project. I'll update that there. We'll start fresh. And I will pull some stuff, but not everything, from... We'll start kind of from this touch one. We're not going to use shapes. We will use label, we will use touchscreen. Yeah, we'll use all of this stuff. Copy the header as well. We'll need tab layout. We'll set the display the same way. Oh, we have this twice. Okay. We're gonna go rotation. 90. These will need to change some. Or actually, I think it's these that need to change. One of these has orientations. Yeah. 90. Okay, calibration stays, but the order of these pins changes. Make a main group. I'll show it on the display. I'll make a font. I will make a tab layout. I'll make groups for each of the pages. We're actually going to only have 3 pages. The rest of that can stay the same. I'm going to make some new tab graphics as well. We've been using this green and gray one that I had showing before here for a little while. But one of the cool things about this tab layout widget is you can actually change the sprites very easily. So you can have tabs that look like whatever you want. So I think I'll make some other fancy tabs for this example once we get the functionality there. I'll make a little bit of content for each page. Let's start with just a label for each page, and then we can always add more as we go. I'll go without shapes for now. We'll just add each label to its page. We'll add the pages to the tab layout. We should have enough room, I think, to use the full word here, maybe. We want to add that to our main group, definitely. We don't need to worry about this. This was basically just showing that you can add new content to the pages after you've already created the tab layout and after you've already created the pages as well. Okay. So this should give us the basic portrait tab layout with the touch functionality. And indeed it does. Maybe I'll go this way. My style, let's go. And in fact, we should, yeah, we can touch as well. We got our 3 pages. They don't quite take up the full amount, so you see there's little spaces in there. The tab layout tries to use the available space as best as it can, but there are limitations based on the size of your sprite. How big the tabs can actually be inflated is what it's called. And so essentially what it boils down to is you have to inflate your tile grid, which is what these ultimately are. They're tile grids. You have to inflate your tile grid to a size that is equally divisible by the tile size in your original sprite. So my original sprites, they're 60 by 48, I want to say. Yeah, 60 pixels by 48 pixels. That means that the tile size is 1/3 of that. So the tile size X is 20 pixels. The tile size Y is what is that, 16? Yeah, 16. So 20 by 16, that's our tile size. That means the total size that we want to inflate to has to be divisible by 20 in the X orientation and 16 in the Y orientation. And it turns out that the actual screen width, which is now in portrait mode here, so it's the small side of the screen, does not divide evenly by that. So that's why we ended up with the extra little spaces in there. The good news is, like, we don't have to care about any of that math. All of that stuff gets handled by the tab layout and the tile grid inflator. So that's one of the things that I think makes this a lot easier to code and to update the code for. Because if we look in the code here, you know, it's doing all the same math. It's just a lot of it in this example exists at the user code layer. Like, let's see here. There's going to be a lot of stuff that's like dividing the screen width, basically. Yeah. So there's tabs height and width here. And then whenever it goes and actually creates the tabs, did I miss it? What are the tab buttons called? Are they button 1, button 2? There's button view 2. Ah, okay, tabs width. That's probably a typo. That's probably supposed to be tabs width, I would think. Maybe not, though. I don't know. These say tabs. Ah, yeah, here we go. So this one is dividing the screen by 3 here. There's a couple other spots here as well where it's dividing the screen size out to figure out some different sizes for stuff. One of the nice things about the tab layout widget here is it will equally divide your screen up based on the number of tabs you gave it. So we just told it when we created it, boom, we want to have 3 tabs. It takes care of all of the rest of that stuff without us worrying about actually dividing out the screen size and all that stuff. So this is pretty nice. So our basic structure is there. That's all it requires. So, you know, it's not nothing. 90 lines of code, a fair amount of white space sprinkled in, but, you know, not nothing, but not quite as much, and just easier. We don't actually get numbers in these things, so I don't know how long that one is. We could download it maybe and see. Of course, we're not done yet either, right? There's still lots of functionality that exists inside this thing that we haven't created yet, so not really comparing right now anyway. Let's try to add the next couple of things. So what all is on the first page here? Full code. Let's close a couple of these. This? Yeah, we don't need that anymore. So page 1 has text with the text box that says a size. I think that's all. What I'll do is play this, and then I'll pause it. Text on this screen is wrapped so that all of it fits nicely into a box that is a certain amount of size. And we have our 2 big buttons on the bottom. And so the way this works is the tab layout actually is like the top, you know, 2/3 or 3/4 or something. I don't know the exact way it breaks down, but it's this portion up here is the tab layout, or is what will be the tab layout when we recreate this using the tab layout. Of course, this one was created long ago before tab layout existed, so it's just using buttons and groups and things. But our tab layout will be this portion up here. I wish I could close this. Anybody know if you can close this? There we go. That'll be our tab layout. We'll have 2 buttons down here. And I think I'll use sprite buttons, which is also a newer thing that I created relatively recently. I will get the background. Let's go here. Go and download this. Good night, Shippu. Remark on the script you updated asked me to run because main and elsewhere. Not all flags for RTC. Oh, gotcha. Yeah. Yeah, I may have forgotten a couple of them. Not all the flags for RTC and temperature sensor were replaced by the if not none. Gotcha. Yeah, I probably forgot a spot or 2 or a couple of them there. I think you see like how it can get replaced at this point, right? Let's grab our image. guess we'll grab all of these, I suppose. We don't need loading, actually. I'm not gonna do a loading. I mean, I guess we could add it eventually, but I think this one is doing loading by having the PyPortal. Yeah. I'm gonna also try to avoid using the PyPortal library as well. I'm gonna try to do things, you know, quote unquote manually without the PyPortal library. That way you could also adapt this program to other devices fairly more easily, at least, because it won't be trying to use the PyPortal library. PyPortal library is great if you are using the PyPortal, but it's not necessary to do the stuff that this project does. And if you want to run this on another kind of device, then you might have to like replace those bits of the code. So we do actually already have all of those things. So let's put our background in, which is BG image. I think the way I will do this is, well, actually the BG image is set for the PyPortal, not the PyPortal Titano. Maybe what we could do is just scoot it on the Titano, put it in a different spot. We don't have any, I mean, we can scale it double, but double is too big. We could scale it up in GIMP, but it will get a little bit fuzzy. Let's start by just drawing it and see how it looks. So we basically want to add a bitmap to our background. The easiest way is we can just use on-disk bitmap. Pull up the Learn Guide for that. Did I say goodnight to Shippu? I don't remember for sure. Good night. Thanks for hanging out. Oh, wait, what? Really not the one. This is the one I wanted this time. There's on-disk bitmap. This one. And we should update these actually, because these, it still has the CircuitPython 6 and then the new CircuitPython 7 way. Still has both of them. We could actually get by with just the CircuitPython 7 way at this point. I think we're getting close to 7.30 beta, or beta's already out. We're getting close to 7.30 release, I think. Okay. So we can just put this on main group, and I guess what we really would need is we want to put it at the beginning. I'm going to call this BG tile grid, and then this to BG. So here, actually, I think as well. I think this will draw it behind the stuff. Oh, I need images. Images. Just center the background. Yeah, I think that'll be what I start with. So for the first one, it's going to be in the top left. Doesn't look the best, but it's not too bad. But yeah, I think we can just go x equals, we're going to go display.width over 2 minus bitmap.width over 2. Same thing for y, but this will be height and this will be height. Yeah. Oh, what is that white stuff at? Oh, the text. Oh, that is interesting. Did you see how it put those pixels from the label, but like before it really rendered the rest of the label? Did you see that? Did I see that? Am I seeing things? Okay. Must also maybe have something to do with the fact that it was there before. Because when it restarts from REPL, it doesn't Doesn't do that. You know, actually, maybe we should put this not centered Y. Maybe we should put this still just at the top in the Y, since we are going to have our 2 buttons down here. And our text is on top of Blinka there, but I think it is in this one too. Yeah, it totally is. So I think that's okay. We'll make this a larger paragraph, or I think it's a sentence or 2 in that one. We'll make it be the same stuff. And then our buttons, we have room for them down here. What does it actually say? The text on this screen. This is calling all of it fits nicely into a text box that is. How do those get filled in? It puts numbers in. Yeah. So it's using PyPortal for wrap nicely, but we have access to that through display text now. Oh, okay. Interesting. I wonder why. I wonder why it does this twice. Because this calls text box with this label, with this, I guess probably Y value, and this string with these placeholders. And then right afterwards, it calls it with all the same arguments, but then this time it's going to fill these in. I think I know. So it doesn't know the size until after it does this once. And so it's trying to print the size of the label. But because it's wrapping, the size of the label doesn't get set until after it does its wrapping. And so it's wrapping this one, then it's looking up the size of the label in order to actually put it into the label. I think what I'll do, I'm pretty sure we have a wrap by pixels instead of wrap by characters, which this one is wrapping at 30 characters, I think. I think we have a wrap by pixels, so we could just put the pixels in before we call wrap. I guess we won't know the height. Yeah, we won't know the height. What I'll start with is just put the width only, and then if we want to, we could come back and do the height later. I think I'll just make a page 1 text. Okay, well, we'll put it on 2 lines then. So to start with, it'll run all the way off, probably. Yeah. So what we'll do instead is look at display text. How does display text wrapping work? I think it just has two. It has wrap to pixels, and then also wrap to characters. Okay, new line dot join, and then we call wrap. Wrap is going to return a list with all of the lines in it. Let's do... Play with -20. Because that'll give us 10 pixels of margin on the left and 10 pixels of margin on the right. It should. Maybe a little bit more on the right because it won't wrap to the exact amount of pixels. It depends what characters are there. Font should just be TerminalIO font. Yeah, which it is. Text on the screen is... Hmm. $320. It is 320 by 40. No, 320 by 480. Found a repo where it makes use of a class myvars. Nice. Cool. Yeah, I'll check that out afterwards. What max width? Maximum number of pixels on a line before wrapping. But what do we actually get for the list? Also, what is the label width? What does that come out to? 294. So that sounds correct. Something is definitely odd though. Do we have scale 2? Scale 2, that's our problem. Yeah. So we actually need to wrap to 1/2 of the size that we are currently wrapping. We're wrapping currently to 300, which is our display width, 320 minus 20, to 300. But because we're doing scale 2 on the label, that means that we actually need it to fit within 150 pixels because everything is multiplied by 2. Everything is scaled up by 2. So we actually just need this over 2. And I'll do the same thing on this one in here. And that should actually give us like either 3 or 4 lines, and that should make our width less than 150. Yeah, 144, which means after we then scale it by 2, it does actually fit onto the display like so. Okay. And then we can still fill in Actually, you know what we can do? After we set it the first time, we could just say page1label.text equals page1label.text.format, because we can still call format on it, I think. And it already still has the curly brackets, so we can just go page1.width, page1.height. Page1 label, not the page itself. Yeah, there's our size. Now, you know, it does, the scaling factors in. So there's a case to be made, like, do we want to multiply these by 2? Since we're actually scaling and therefore in double the amount, right? Probably doesn't matter too much one way or the other. We could always just give it here. This, multiply by the scale. GPS datagram. Datagram, I think, is the word I was trying to think of earlier. That's what the async learn guide, I think, calls it. Yeah. Yeah, so this one, it creates a class, it keeps a list of strings, and then you can update the strings. You can read particular ones out of it, and then you can clean, which it looks like is setting it back to empty. Yeah, something like this would work. This would, if we refactored it to use something like this, then it would definitely get rid of the globals, I'm pretty sure. This one should work the same, just the one difference is the scaling here, so it tells us 288 and 178 is the size of the text box there. And then the background will stay there on every tab. Fetches aren't quite... I think maybe I wasn't pressing hard enough, or just not in the right spot. I don't know. I wonder if our calibration does need to be modified, actually. Also, like, such a weird angle. I don't even know if I'm touching the right spot, truthfully, because it's like, so I have it like leaning away from me so that the glare from the camera doesn't come back into the camera. So I'm like, it's kind of like angled down and away from me. It's tough to see where I'm actually pressing. Let's make the buttons at the bottom for the NeoPixels. Yeah, well, one of them changes the color of the NeoPixel, and one of them turns it on and off. And this one is just using button, which we could definitely use button. I want to make it a little fancier, I think, though. I think I'm going to go with sprite button. And one question will be is the size. How big do we want to make it? Why is it so slow to change the page? Just because, like, internally it has to redraw the bitmap that represents the screen. It just depends on how much stuff you have showing on the page. And then, like, the display, like, that speed that you see there, that's basically just the speed that the display updates. And the larger your display, the longer that takes too, right? So, like, if I switched over to the regular PyPortal instead of the PyPortal Titano, that will actually move quicker because it's fewer pixels. The other thing is, like, maybe there is... Yeah, like, this one didn't have to change as much, so it kind of can go faster. But then the one that does have the larger label does take it a little bit longer. And I think that's just that's like limitation of CircuitPython. Honestly, I don't think there's anything at the user code or the library level we could do to make that faster. Now, internally inside DisplayIO, maybe there is some efficiency gains. Like, I don't know if it's like, I don't know, maybe it's redrawing every pixel, even the ones that haven't changed. Possibly there could be a chance to not do that as much. Only try to only update the pixels that have changed. Maybe something like that could speed it up. I think that's the reason though. Is I think that's just that's the refresh rate. That's as fast as the this particular microcontroller can send data to this particular screen, and this particular screen can push it to the actual pixels. So one thing, yeah, sprite button. We put labels on sprite button, I think. Did we? Oh. We could make this out of draft, actually. Because the core one is in now, and also the tile grid inflator is also in. Yeah. And image load is where that ended up. So I think our screen is 320 by 480. So if we wanted our buttons, in this example, they take up basically half of the screen. So they would be 160? Yeah. Go farther than that. Well, let's try like that. And then rounded. Make rounded buttons. All right. And I think let's go like a lightish gray for the outside. Then bring it in some. And what do we want to do on the inside? Actually make it a little bit wider of a gradient there. I like that. That makes kind of the weird in-between color kind of big, actually. I do actually like it better, smaller. Yeah, let's do it like that. Okay. Let's go deselect, which is Control-Alt-A, I think. No, Control-Shift-A? Deselect? None. Shift-Control-A. Select. One thing is we actually got transparency on the outside. Which we don't really want. We want the outside to be sharp. Okay, that actually did change it to sharp. Okay. Let's go color map. Let's make sure pink is first. Wait. And it is. Big old, that's a big color map right there. Export this. I already have that fancy button 1 it is then. Maybe I should put 160 by 160 also in the name, actually. Is that an example? I didn't add an example. Good. Really, I have an example though. And I'll load both of these. I think I'm gonna, for now, just set them to the same one. Fancy. Oh no, did I save it as a PNG? We don't need PNG. Oh, fancy button 0. We'll set them both to the same for now. Eventually I'll come back and change it so that it can be like oh, this is not sprite button though. Yeah. This one was just tile grids. Here we go. Yeah, that's what we want. We'll go x0. We'll go y display height minus 160. I don't know why sometimes it wants to like import this longer chain. Width and height, I think we can leave those off. Let's find out. It does not use the, this one just uses the paths. Maybe that's how we should do it, though. Transparency index is going to stay 0 because that's where our pink is at. Button 0. That does. Well, we don't need these actually. Let's turn those off. Missing width, so we do need width. I guess we'll go 160. Or is this in tiles? I need to close that because that's actually tile grid. Button width. No, that looks like pixels. I multiplied it by tiles. I think it's pixels though. Oh. 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 That's not what we expected. Oh, that's a different button. Yeah, we did fancy button 1. That's an even fancier button, although it looked kind of messed up because it was supposed to be round. How it must... Huh. Does it not? I think it would. Why wouldn't it? What's the size of the label? I mean of the bitmap? $160. Oh, 160 doesn't divide by 3. That's actually our problem, I think. It's 59? It's 7, 6. Yeah, it should. Should it? Or yeah. Maybe let's do that. So I believe this does want your sprite to be divisible by 3 because of the way the inflator works. In this case, we're not actually going to be inflating it to a larger size. It's going to stay the real size that it is. Maybe we should make an exception in the sprite button that will make it allow that. Okay, there we go. So the gradient looks a little weird, especially through the camera at this angle, I will say. It looks a little bit better to the naked eye. But it is, I mean, you can still see the diagonal defined in there pretty well. But I will say the camera is honestly making it look a lot weirder, a lot worse. It's also kind of blinky in there with the refresh rate, which I don't see that at all in person. That's interesting. Let's do a scale up on the text. I think we can just do label scale or something, or... lib button. Here. Oh, we don't have label scale actually. Self.label. I guess we could always just go self like button.label.scale. Let's call this the on-off button. Oh. Right, no, we can't do that because label it's like a string when you set it, or I mean when you access it. I think it doesn't I think it converts when you set it. Let's see what this is. My wife's texting me here. Okay. Nice. Okay, cool. Yeah, I'll check all the updated stuff out after the stream. Dropbox there. I've set it back as well. We can close this. Okay. I think this has like, yeah, label. So label, it returns the text. We actually don't have a way easily to scale it. I mean, you could give it a different font. Would work, I guess. This one not have a scale on it? Full font color, yeah. Like we could, you know, use a bigger font that would just look bigger instead of scaling it. That would work. Be nice if we could just scale the label too, though. I mean, we could probably do this, even though it's not like not supposed to. Air quotes, underscore. Does look a lot better though. We try 4? Let's try 4. Well, it does. It's getting off center. 4 looks pretty good. It is getting off center. I wonder why. For ad folk like myself, the long intro makes it almost impossible to get into the meat of the session. The long intro? To the video? You mean, Patrick, on YouTube there? I mean, I like to give the intro every time just because there can be new folks, like, who don't know at all what we are talking about. I try to keep it brief because there are, like, I think the majority of people watching are very likely like know what we're dealing with, know what's going on, probably have watched before. But I do want to make sure, like, if we do have new folks, which, like, people do reach out to me after the different streams, I've had folks reach out and be like, you know, this was the first time I watched anything like this. So I do want to make sure that we at least give them a little bit of grounding in, like, what we're actually working on before we jump straight in. I do sometimes do streams on other days of the week, though, where I will just, like, not do nearly as much of an intro or an explanation and just jump straight in and start working. So I would encourage you, if that's the kind of thing you want, like, just more like get right to work and not do as much of the interactions and the introduction, you could follow me on Twitch or watch the live chat channel on the Discord, and I'll post in there when I do streams sometimes as well. So you can maybe find one of those other ones, which is where the format's a little bit different and it's not quite as interactive, and I tend to just jump in much quicker. I think it would be super nice if we could just go label scale like this. We can't currently, but I think it would be nice if we could. I'm probably gonna be heading out also before too much longer. Not sure also what you mean for add folk. ADD folk, I'm not sure what that means. Oh, ADD, probably, not add. Maybe I do know what that means. Just had to actually say it out. So this is kind of off the beaten path a bit, right? Because this doesn't actually exist, and I'm just kind of adding it real fast like this, but I think that will make it work. Might actually make it center correctly still too, but maybe not. I'm not sure about that last part. No, yeah, it's not. It is still messed up. Yeah, this is why right here. This is not accounting for the scale. Oh. Well, hold on though, because width and height here actually are they pixels? Okay, this is some kind of logic that's if it's too wide. Yeah. It's trying to like remove characters until it fits. Actually, no though. Would it be self width? Print self width? So does this value look like pixels or tiles? Pixels, 160, okay. So dims 2, actually. This, I think, is what needs to be multiplied by label scale. Then I think this will put it centered. Check. Also, I got another message from my wife. Okay. So it is centered horizontally now, which is nicer. I do notice it's not actually centered vertically, but that's just because Y value here. Actually, that should be half height. Maybe it is centered vertically. Doesn't look like it to my eye. Also, the diagonal might make it trick of the eye, kind of make it a what do they call that? Trying to blank. Optical illusion. That's what I'm after. I think it's not, though, honestly. I think it's farther down. Maybe the half height does not take into account the scale either. That could be. That could very well be. I don't actually know for certain. That's what it feels like to me, though. And so right now we don't, I guess we should default the text to off, but also we don't have any touch logic on this either. I think it has contains. If I recall correctly, that has a contains. Yeah. We got our button presses there. And so we could have it change to show you that it's been pressed, and then of course we would switch the label to on. We'd have it turn on the light, and then our other button over here will be for changing the color of, it'll be the NeoPixel on the back. I think I'm gonna wrap it up for here, though. Oh, how's it going, Johnny? Thanks for joining us. I do think I'm gonna head out here pretty quick, though. I will be back tomorrow morning. So Saturday mornings at 10 a.m. Central Time. That's when I do my other weekly stream. So I mentioned at the beginning, I'm taking over this one, Deep Dive, for Scott for a while. But even prior to that, I have been doing my Saturday morning streams. I don't have a good name for it, really. Maybe I'll just call it Deep Dive with Tim on Saturday, or just call it Deep Dive also or something. I don't know. Maybe we'll think of a good name one of these days. But Saturday morning at 10 a.m. Central Time, that was my normal stream schedule before I started doing the deep dives, and I am keeping up with that as well. So I'll be back then tomorrow morning at 10 a.m. and I'll probably be working more on this. I don't know for certain. I might get inspiration to work on something else in the meantime, or earlier on in the morning, so we'll see. But probably, I think as of right now, I'll probably just pick up where we left off here. So if you're interested in kind of watching the progression of this project, creating the other button, and then obviously creating the content for the other pages, then come hang out tomorrow. I'll drop the links in that live broadcast chat room, which is where the same chat we have showing on the screen right down below me there. So if you head to that room, you can always find the links when I do start streaming. Yeah, thank you, Foamy Guy, DFG. You're welcome for sure. Thanks for watching. Thank you to everybody else who is watching. Dexter, Paul, definitely. Huge thanks to Paul for the example that we were working on earlier. Johnny, who else was around? Deshipu left a little while ago, I think. Who else did we see today? I think we saw a couple other folks. Tammy, Struds, again, thank you for watching and for your nice comment. Hari, thanks for hanging out. Who did we have? Smart Gambler, thanks. Love the Factory, how's it going from Colorado? I don't remember. I think I said hi, but maybe not. If so, I apologize. Tammy and Liz were here at the beginning. Yeah, I think that's who we got all the way there on Discord. Beata, DFG, Hari. That's who we got. Patrick as well over on YouTube. So thank you to everybody who's watching. Again, I'll be back tomorrow morning, 10 a.m. Central. I don't know for sure about next week deep dive. I still need to work with Scott. We might do a joint one, or he might do one, or something. So possibly next week deep dive will involve Scott, but don't quote me, right? Because I don't know for sure. I still need to talk to him. So maybe it's still me next week. Maybe it's a joint one. Something, you know, there will be a deep dive one way or another, but we just don't know exactly what it will be just yet. So tune in next week for that. And yeah, I'll see you all next time, tomorrow morning, if you want to catch that stream.